Today we want to look at, I want to answer a question. The last class I told you we are going to do floating point and fixed point representation. But before then, let me answer the question. Are we still doing mathematics? Yes, I am teaching you mathematics in action. Now, even though we have been discussing bits, I have used two types of mathematics. Probably I have not mentioned the names, but I'm going to explain them in this class for you to see. Now, if you have something like this, if you have 2 raised power n equals to what? N. And then we have log 2n equals to n. See, this is what? Indices. And this is what? Logarithm. I'm sure you've seen these two mathematics. Now, this is what? Creation. And then this is what? Revelation. Every other mathematics is in between. Is in between these two. Right? So, what I have been doing is to bring mathematics down to the layer of machine. And in machine, we are dealing with what? Voltage. So we are dealing with voltage and what? Current. So this one gives birth to what? Electric field. This one gives birth to what? Magnetic field. The dance will give you what? Electromagnetic field. Electromagnetic signal or field. Right? Now, this is a continuous state, but we are looking for discrete state. That is two-state solution, 0 and 1. So we'll bring in a transistor and we use the concept of threshold to achieve it. And I told you in one of my previous classes, we are looking at the concept of mercy and grace, right? If you look at my previous videos, you will see it. Now, this is what we are trying to achieve. So this is the two types of mathematics we have used, indices and logarithm. So I am looking at bit and the patterns that this bit combination can give you. So today I'm going to use these two mathematics to explain a complete pattern for you to see that we are still doing mathematics. Let's say I have 4 inputs, which is what? A, B, C, and D. Now, how many patterns will this give me? Following that mathematics, which is what? 2 raised power n. So this will be what? 2 raised power 4. And that will give me what? 16. That is indices. How many patterns can I get from this number of bits? But what if I'm given the pattern and I'm supposed to get the number of bits? That is what? Log 2, because we are using binary. 16 equals to what? 4. So how did you get this? Let's say we have log 2, 16 equals to what? X. I'm asked to get the number of bits that will give me this. That will be what? 16 equals to what? 2 raised power x. This is 2 raised power 4 equals to 2 raised power x. So this will cancel this one, and x equals to what? 4. So that is logarithm and indices. Indices is creation. Logarithm is what? Revelation, taking you back to the origin. That is why 2 raised power 0 equals to what? 1. You can see 0 dimension will give you what? 1 pattern. That is very powerful, meaning unity is obtained from this. So anything outside of 0, we are having choices. That is very powerful. I don't want to go into that, but I'm just trying to show you how they've been showing you mathematics all along. But all you see is religion, but it's pure mathematics, right? Now let's see. how we can actually achieve that. And in the machine, these are what? Four switches. So I'm having 0, 0, 0, 0, right? 0, 0, 0, 1. Now, you begin to see the pattern that I'm forming. 0, 0, 1, 0. 0, 0, 1, 1. 0, 1, 0, 0. You can see 0, 1, 0, 1, 0. So 0, 0, 1, 1. So this will be 2, 0. Now 4, 0, 0, 0, 0. So this will be 4, 1. So this will be 0, 1, 0, 1. See the pattern? 1, 2, 3, 4, 5, 6. So I have 0, 1, 1, 0. Then 0, 1, 1, 1. So let's stop. This is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7. So let's bring 8 to this side. We still have the same pattern again. A, B, C, and D. Now, continuation. So here will be 1, because we already have 1, 2, 3, 4, 5, 6, 7, 8. So the remaining 8 will be 1, 0, 0, 0. So 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 1. Right? 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 1, 0. And then we have 1, 1, 1, 1. So this is 8, this is 9, this is 10, this is 11, this is 12, this is 13, this is 14, and then this is 15. So if you see, you will see the pattern 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. Then you have 1, 2, 3, 4, 5, 6, 7, 8, and then 8 zeros on this side. Now that is how you get the pattern. So you can see that these 4 bits total combination is what? 16, meaning the bit equals to what? Dimension, right? And the patterns, right, equals to what? Universe. So how many universe can we get from the bit that is given? That is basically what I have been trying to show you. So at this point, we still don't have meaning attached to it. So we are just looking at 4 switches. So it means that these 4 switches are off. Only the 4th switch is on here. The 3rd switch is on here. 2 switches are on here, right? Only 1 switch is on here. 2 switches are on here. 2 are on. 3 switches are on. 1 switch is on. But the position of this bit is what we call weight, right? And I've shown that to you what in positional number system. So the position will determine the value. So at this point, you are not seeing any value. But when you check the position of this bit in different states, like in this binary, so this will be what? 0, this is 1, this is 2, and then this is 3. So that will tell you what this value is, which is what? 8. Because this is 2 to the power 3. That is 8. Why this other one will give you 0? So this is 8. Now, how do you get this one to be 9, which is the value? By looking at the weight, the position of the on bit, which is the 1. So you can see how we are deriving meaning from all these combinations. So it is mathematics. At the abstract level, where you are given all those your equations, you are seeing the mathematical equations. But when you push them down, or you get to the point of the hardware, the point of physics, then you begin to see the practical application of that mathematics at the lower layer. So we are doing mathematics. I'm only showing you mathematics in action. So that is what I want to show you. I want to explain in this class. So the next class, we are now going to look at the fixed point and the floating point representation of what? The radix point. So we'll look at that in the next class. So if you are clear with this, don't forget to give me a thumbs up. And if you have not subscribed, please do so that you see the subsequent videos that I'll be releasing in this topic. So till we see in the next class, bye-bye.